Welcome back to Java Internal's Crashcasts. I'm Sheila, and I'm here with Victor to dive into the exciting world of reactive programming libraries. Today we're focusing on two popular libraries, RxJava and Project Reactor. Before we start, let's kick things off with a quiz question for our listeners. Victor, would you like to do the honors?
Certainly, Sheila. Here's a question to ponder. In a system processing millions of events per second, which of the following is not a primary benefit of using reactive programming libraries like RxJava or Project Reactor? Is it A, improved performance, B, better resource utilization, C, automatic garbage collection, or D, enhanced error handling?
Ooh, that's an intriguing question, Victor. It really makes you think about the core benefits of reactive programming. Listeners, keep that question in mind as we explore these libraries. Now, let's start with the basics. Victor, can you give us a quick overview of what reactive libraries are and why they're important?
Absolutely, Sheila. Reactive libraries like RxJava and Project Reactor are tools that help developers build asynchronous, non-blocking, and event-driven applications. They implement the reactive stream specification, which we discussed in our previous episode. These libraries provide a way to handle streams of data with backpressure, allowing systems to be more resilient and efficient when dealing with varying loads of data.
That's a great explanation, Victor. So, if I understand correctly, these libraries are like superpowered plumbing systems for our data, right? They help us manage the flow of information smoothly, even when there's a lot of it or when it comes in bursts. Is that a fair analogy?
That's an excellent analogy, Sheila. Imagine a conveyor belt system in a factory. RxJava and Project Reactor are like smart conveyor belts that can speed up, slow down, or even pause based on how quickly items, or in our case, data, are being processed at different stages. This helps prevent bottlenecks and ensures smooth operation throughout the system.
That makes a lot of sense. Thanks. Now, let's dive a bit deeper. What are some of the key components or concepts in these libraries that developers should be familiar with?
Great question. Let's break it down. Both libraries have similar core concepts, but with slightly different naming conventions. In RxJava, we have Observables, which are streams of data that can emit multiple items. Project Reactor uses the term Flux for the same concept. For single-value streams, RxJava uses single, while Project Reactor uses mono. Both libraries also provide a rich set of operators for transforming, filtering, and combining these streams.
I see. So it's like we have different types of conveyor belts for different purposes. Some carry multiple items, while others are designed for just one item. And we have tools to manipulate what's on these conveyor belts, right?
Exactly. And just like in a real factory, these tools, or operators, allow us to do things like filter out defective items, filter operator, combine items from different conveyor belts, merge or zip operators, or transform items into something else, map operator.
That's fascinating. Can you give us an example of how these concepts might be used in a real-world scenario?
Certainly. Let's say we're building a real-time stock trading application. We could use an observable or Flux to represent a stream of stock price updates. We might use the filter operator to focus on stocks above a certain price, the map operator to convert the raw data into a more useful format, and then use the subscribe method to perform actions when new data arrives, like updating a user interface or triggering a trade.
That's a great example, Victor. It really shows how these libraries can be powerful in handling real-time data. Now, I'm curious about the differences between RxJava and Project Reactor. Are there any significant distinctions developers should be aware of?
Good question, Sheila. While both libraries serve similar purposes, there are some key differences. RxJava has been around longer and has a larger ecosystem, especially in the Android development world. Project Reactor, on the other hand, is more tightly integrated with the Spring framework and tends to have better performance in some scenarios. Project Reactor also has a stronger focus on backpressure handling out of the box.
Interesting. So it sounds like the choice between them might depend on the specific project requirements and ecosystem. Are there any common pitfalls or misconceptions that developers should be aware of when working with these libraries?
Absolutely, Sheila. One common pitfall is overusing reactive programming. Not every part of an application needs to be reactive, and sometimes using these libraries can add unnecessary complexity. Another issue is forgetting to handle errors properly. In reactive streams, errors terminate the stream, so it's crucial to use error handling operators like on-error resume or on-error return.
Those are great points, Victor. It reminds me of the saying, when you have a hammer, everything looks like a nail. We need to be mindful of using the right tool for the job. Now, as we're nearing the end of our discussion, could you share some best practices for working with these reactive libraries?
Certainly. Some key best practices include 1. Start small and gradually introduce reactive programming to your codebase. 2. Use operators judiciously and prefer simpler solutions when possible. 3. Always handle errors and edge cases. 4. Be mindful of subscription management to avoid memory leaks. 5. Use testing libraries specifically designed for reactive streams, like Test Subscriber for RxJava or Step Verifier for Project Reactor. And remember, the goal is to make your code more manageable and performant, not just to use reactive programming for its own sake.
Thank you, Victor, for those valuable insights. Before we wrap up, let's reveal the answer to our quiz question. The correct answer is C, automatic garbage collection. While reactive programming libraries offer many benefits, including improved performance, better resource utilization, and enhanced error handling, they don't directly affect garbage collection, which is a function of the Java runtime.
Excellent point, Sheila. It's important to remember that while reactive programming can help us build more efficient and resilient systems, it's not a magic solution for all programming challenges.
Absolutely, Victor. To summarize today's episode, we've explored RxJava and Project Reactor, two powerful reactive programming libraries. We've discussed their key concepts like observables, Flux, and operators, and how they can be used to handle asynchronous data streams efficiently. We've also touched on their differences, common pitfalls, and best practices for implementation. In our next episode, we'll be diving into the exciting world of concurrency in Java 9 and beyond, exploring new features like var handle and improvements to completable future. Don't miss it. If you've enjoyed this episode, please subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue to bring you in-depth explorations of Java's inner workings. Until next time, happy coding.